Hello friends, this is Manik Mehra and today I am going to start my topic, that is addressing modes and its working. It plays an important role in computer architecture and for the beginners to know how the operands are stored in a memory and how their effective address will be calculated. So in my index, different types of addressing modes which I am going to explain. First one is immediate. So immediate addressing mode itself having an operand in its instruction part. There is no address which is actually given in this addressing mode. The direct operand is given in this addressing mode. For example, in my presentation, add AX, 5H. H stands for hexadecimal. So in AX register, hexadecimal 5H, add 5 to contents of the accumulator. Accumulator is basically the processor register. So 5 is the operand, so 5 will be directly added to the accumulator. As we can see, there are so many advantages of immediate addressing mode. Just like there is no memory reference, as I have told earlier, no memory reference is there, so there is no need to find any effective address. It's very fast. So the next concept is direct addressing mode. There are two types of addresses, friends. First one is direct and second one is indirect. Direct address is what? The address field of the instruction format is having an accurate address of an operand. It means that the operand wherever stored in the memory, its effective address. So effective address is equivalent to address field of its part. So add AX, value. It means that add contents of cell value to accumulator AX. It means that the address which is given in the instruction is having the operand on its storage capacity. The memory which address is given having an operand. So there is a need of single memory reference to access data from the memory, and limited address space is a little bit disadvantage. Just like in this diagram above, given is your instruction format which is having operation code and operand field. So A is stored in memory. A is basically an address on which the operand is stored in the memory. So this is the addressing mode which is to be known as direct addressing mode. Next one is indirect addressing mode. Indirect addressing mode means address is having further address, means that pointer. So memory cell pointed to by address field contains the address of the operand. Further address. So effective address equals to address. We can better understand through a diagram. For example, in the direct addressing mode, address which is given directly having operand in the memory. But in this diagram we can see or we can observe that address is having further address to the operand in the memory. So this is the difference between direct address and indirect addressing mode. So next we are going to start resistor addressing mode. Any addressing mode who doesn't have any address in its address field but having any resistor, name of the resistor in the addressing field, processor name of the resistor, processing name of the resistor, that is to be known as resistor addressing mode. It's very fast in nature, but a system is having less number of resistors, or you can say that limited number of resistors, so this will be a disadvantage. So effective address is equal to R. R means resistor, the name of the given resistor. Very small address field needed, shorter instructions, but as I have talked earlier that its fetching speed is very fast, so that's why it is highly useful. Just like for example move AX, BX. So there are basically in hypothetical system 4 resistors, AX, BX, CX and DX. So AX, BX, first resistor is your source resistor and second one is your destination resistor. So this is the syntax of move instruction, and second one is add. This is the example. In the address part, R is the resistor name which is having operand. So that's why it is to be known as resistor addressing mode. Next one is resistor indirect addressing mode. It means that the name of the resistor which is given in the address part is having address of the operand. So it means that effective address is equivalent to R. Just like in this diagram, in the address field R is given and R is having the address of operand which is already stored in the memory. So that's why this is the difference between direct resistor addressing mode and indirect resistor addressing mode. So the next some addressing modes are very important. In this addressing mode, the effective address will be calculated through the addition of displacement of another resistor which is given in the addressing mode. For example, as in the presentation, effective address is find out by adding the start address with the displacement of resistor given. For example, there are basically three types of these kind of addressing modes. First one is relative addressing mode. The one resistor which is having name just like PC, program counter, which always having the address of the next instruction which is to be executed. So in this addressing mode, the effective address will be calculated through address plus PC, contents of the PC, the address of the PC. So you will get operand from A cells from the current location pointed to by PC. So it means that effective address in the relative addressing mode will be calculated by address plus contents of PC. Next is base resistor addressing mode. Base resistor is a kind of resistor which is having base address, the address of the memory from which it is started. So that's why in this addressing mode, effective address will be calculated through address plus the base resistor starting address. Next one is indexed addressing mode. There is also one resistor that is having name XR, which is also to be known as indexed resistor addressing mode. In this addressing mode, effective address will be calculated by adding the address part of the instruction plus the displacement which is given by the XR resistor. So friends, I hope it will be very helpful for you all to know all about the addressing modes and its working. Thank you so much.